Working on 3s and 6s. And in yellow crayon, you need to be drawing a 3 by 3 array. And then please label it 3 by 3. I don't know why it's making me do it this way, but that's okay. So here's our 3 by 3 array. So now you should have drawn a 3 by 3 and then a 3 by 6, one in yellow and one in red. That's fine. How are these two arrays similar? How are these two arrays similar? So we have our 3 by 3, and then you have a 3 by 6. How are these similar? Kate, how are they similar?
Because the 3 by 6 is 3 by 6.
Beautiful. They are similar. Because the 3 by 6 is made of 2 3 by 3s. I love that. I love that. If you pick up my 3 by 3 and you double it, it will go 2 times on my 3 by 6. I'm writing, therefore you should be writing. Any other way you noticed they were similar? Anything else? What are you thinking, Kylie?
It's the regular card, but
they each have 3 rows. I like it. How else are they similar? Dorian?
They all have 3s.
What do you mean?
Like, so in every single one, they have 3 groups. Like 3 times 3, there's 3 groups of 3, and then 3 times 6, there's 3 groups of 6.
All right, so this is kind of what Kylie said, are in groups of 3s. I like it. I like it. Is there anything else that you noticed about how they are similar? Kylie asked me a good point. She said, hey, your array is going sideways, but my array is going up and down. Is that okay?
Yes. It's the same thing.
Why is it okay? Because it is not the same thing. Her array is going up and down, and mine is going side to side. They look very different. Why is that okay? Lily Marie? They equal the same amount? There's a fancy math term for that. Really? Yes, because of the commutative property, you can make your array go up and down, or you can make it go side to side.
Up and down one is diagonal.
Sure.
But it will still equal the same.
It'll still have the same value. We want to make sure we're matching our picture to our equation, but as long as we have the same value, we're good. Great question, Kylie. All right, we're going to work in the hundreds chart. Oops, I'm writing in yellow. What is this? We're going to work in the hundreds chart. I'm going to give you a hundreds chart. We're going to color in our 3s with yellow. What's going to be the first product that I color? Barrett? 3. 3 is going to be first. Oops. Man, I wish my board would work. 3 is going to be first. What's next? What's next? Kylie, what's next? 6. What can I do if I don't know my 3s? How do I figure out what the next one's going to be? If I don't know what's next, how do I figure it out? Because some of you know 3, 6, you know your multiples. Some of you don't. How are you going to figure it out if you don't? Barrett? Count on. 6, 7, 8, 9. 9 is my third one. 9 is the next thing I color. 9, 10, 11, 12. 12 is my third one. 12 is what I color. Does that make sense?
Yes.
Please go slow. This one is going to have a trickier, it will eventually start to have a pattern, but it's going to be much trickier. You can't erase crayon very well. So be consistent on where you're putting your 3s, okay?
Okay.
Okay, when you get it, you may glue it in and then start working on your 3s. So go ahead and get out a glue stick. We notice that it is a pattern. I'm writing there for your writing. You can put it on the same page as your multiplication chart. The 3s make a diagonal pattern. We notice that the 1s count down going on the diagonal. So if you pay attention to the 1s in each of the products as you're going down, it's kind of counting down. And then we also noticed that the products, what we're coloring in, are both sometimes even and sometimes they are odd. They're not all even or all odd, they kind of change. So I'm writing, therefore you should be writing. This will be done in pencil. Alright, so we're looking at our 3s. 3 times 0 is what, Ashlyn?
3 times 0 is 0.
0. 3 times what? 3 times 1 is what, Cade?
3.
3. Dorian, 3 times 2. 3 times 2. What's 3 times 2? Okay. What's 3 times 2?
3 times 2, that equals 6.
Perfect. 6. Now we have our 3 times 3 gap right here. 3, 6. What's next? 9. Fill in our 9. 3, 6, 9, 12, 15,
18.
18,
21.
21,
24.
24, 27, 30.
Now I'm going to go down.
Build out all our 3s. We're done, right?
No.
What you mean, no?
We still have to do.
Gio, what you mean, no? Why? Why? Why do you have to do the ones going that way, Dorian? The commutative property, which says what? What does that mean? What do those words mean? Go ahead, Dorian.
You can switch it around and it can still be the same product.
Oh, I love that. I can switch it around and still equal the same product. So let's go across. 3 times 0 is what, William? 0. Billy, 1 times 3. 3. Aiden, 2 times 3. 6. Lainey, 3 times 3. 9. Lily Marie, 4 times 3. Should already be written in your notebook. You just got to find it. Three, 6, 9, 12. Very good. Mason, 5 times 3. 15. Oh, we got an empty one. 3, 6, 9, 12, 15, 18, What's next? 18,
21,
24,
27,
27, 30. Very good. We have only a tiny, tiny bit left, and we're actually going to fill in a lot of that in a moment. So 3 by 2 in red. So I got my 3 by 2 in yellow. And then I have another 3 by 2, what did I say, red?
Yeah.
2. And then we're going to make sure that we label them. This is our 3 by 2, and then our other 3 by 2. So you're doing this with your crayons in your notebook. Yes. Quickly. Alright, we've kind of already talked about this, but how are we seeing that our 3s are related to our 6s? How are 3s and 6s related? Billy? So they are, what's that word we did with 2s and 4s? Nope. Cade? They're doubles. If you double your 3s, you're going to get your 6s. So underneath that, I want you to write 3s doubled equal your 6s. They are just doubles. They are just doubles. If you double your 3s, you're going to get your 6s. Y-O-U-R. Yes, it's just all smushed together in there. Dorian? What's that? Okay. Kylie, what? Yeah. And I'm going to prove it to you that they are doubled. So go back to your hundreds chart. The one we just colored in with our 3s looks like this. But instead of coloring with red, we're going to color with blue, same color that we always do. And we're just going to color in our 6s with blue. That's why I said with blue. So the first one I'm going to color in is 6. Oh. And then the next one I'm going to color in is 12. Yep. Count on and do all your 6s in blue to make that greenish color. Can I tell you a shortcut? What? If my 3s are already doubled, I just need to color in every other 3. So I'm going to do, here's a 3, I'm not going to color it in, I'm going to color in this one. Skip a 3, color it in. 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 Since it's doubled, I'm just doing every other one. It should look something like that. We only have a few things left to fill in. We have to fill in 6 times 6. I know that 6 times 5 from my multiplication chart is 30. So I'm going to add one more group of 6 from 30. What is 6 times 6? It's really that simple. Lainey? 36. Fill in our 6 by 6 box. Why are you green? All right, let's add another group of 6. 36 plus 6. It's going to give us 6 times 7. What is that going to be, William? 42. Very good. Add another group of 6 to get our 8 times 6. Billy? 50, not 58. It's not 50 anything. 48. There we go. We're done? Filled in all of our 6s?
No.
What am I missing? What am I missing? Gio, what am I missing? We have to do sideways. Why do we have to do the sideways? What does a commutative property say? Aiden? Sum correct for addition, product for multiplication. Order will not change my answer, right? Yep, order might matter for my picture, but it's not going to change for my answer. All right, we filled in 6 times 6. What about 7 times 6? Add one more group of 6 onto that. Barrett, what's 7 times 6? No, that would be 6 times 6. We already have that filled in. 42. Very good. One more group of 6, Hunter. 42 plus 6. Yes? 48. Oh. We have almost finished our whole multiplication. Tomorrow, we'll finish our 7s and our 8s, and we will be all done with our multiplication facts. That does not mean that we will not multiply ever again. In fact, we have a whole nother unit where we will multiply all over again, but we'll focus more on the word problem part. Okay? We have talked about using 3s and doubling our 3s. However, we've kind of also talked about if we're using a break apart strategy, you can break it apart in any way that works best for you. So if you are really good at using your 3s, then you might break apart. Mason, you got this title down? If I have the problem 6 times 7, I could definitely use my 3s, because they're my doubles, and break apart my 6 into 3 and 3, which would give me 3 groups of 7 plus another 3 groups of 7. This is a good way. My brain is not super happy with 3s. If your brain is, this is fantastic. Mine not so much. But I know that I can break up my 6s any way I want. So I'm going to do this again. But instead of breaking up to 3 and 3, an easier way, Gio, you should be writing, for me to break apart my 6 using math fix that I know. 5 and 1. 5 and 1 equals 6. I'm totally a master at my 1s. Definitely a master at my 5s. So now this is going to be 5 groups of 7 plus 1 group of 7. Kylie, you should be writing. I want you to either do the 3 version or the 5 and 1 version to solve 6 times 7. Whichever makes your brain happy, solve it in your notebook. Alright, a lot of you pick 3 and 3, but you don't know 3 times 7. That's a problem. You can't pick that strategy if you don't know that math fact. Billy, what's 5 times 7? Since I know you're paying attention in math, not reading a book in your desk.
5 times 7 is
40.
40.
It's not 40.
It's 30.
Try that again. Skip count real quick. 35. There we go. What's 1 times 7? It's 1 times 7. What is it? Really? 7. 35 plus 7?
Wait, 35 plus 7?
Yes. Ada? Ada, 35 plus 7. That's my answer. Right there. If you don't like 3 times 7, don't do it that way. Break it apart with 5 and 1. I will prove to you that it works with 3 times 7. Does anyone know what 3 times 7 is? Kate?
3 times 7 is 21.
Yep, so I have 21 plus 21.
That's what I did.
Which equals what, Kate?
So what I did, I took the two, I took the 2's from the 10th place and added them together to about 40, and then I got the 2's from the 1st place to get A2, and then I added them together to get A2.
Both ways give you the same answer. It's just a matter of how you want to break it apart. People lining up outside is not interesting. Stop looking outside and start thinking up here. So, as we start working on the more tricky math facts, I want you to be thinking, how can I break it up into easy math facts that I already know? Does this make sense?
Yeah.
Okay.
Do the numbers have to be even?
What do you mean?
Break them apart?
Just has to add to whatever you're breaking it into. So, like, I can't say 2 and 1, because 2 and 1 does not equal 6. Do you see what I'm saying? Yep, it has to match what you're breaking apart. Alright, we are going to stop here. Go ahead and put away your math notebook. Make sure you have these strategies, because you're going to see them again.
And this one's already fixed.
No, it doesn't.